We're continuing with our 3D models. Today we're looking at spheres. So previously we talked about cylinders, and cylinders were a circle that had been extended with some sort of height, kind of like a can shape, but it still has that circle base. And we're talking about volume, what fills inside of that. So today we're still talking about a circle, but in this case the circle is being rotated around 360 degrees, creating a sphere or a ball shape. Okay, so a basketball, a globe, just basically any sort of round spherical object. But we're still trying to find the inside, what fits inside of that ball. All right, so if we're giving you a little picture here, if you want to make this in 3D, you just make yourself a circle, and then, this imagery right here just kind of creates it in 3D, gives it some dimensions. All right, and just like on a circle, there's the center of this entire sphere. And on a circle, anywhere from the middle to the edge of the circle is called the radius. The same thing for the sphere. From the middle of this sphere to anywhere on the edge of it, doesn't just have to be on this middle part, but anywhere. Say from there to there, to the edge of that, that is a radius. I could also go from here, just any random point out here, that's also the radius. So any of those is the radius as long as it goes from the center to the outside. Now, but what we're trying to find today is the volume of a sphere. So the volume, V, of a sphere is 4 pi r, and r is radius, cubed divided by 3. Okay, so you can make a note of that. So 4 times pi times the radius cubed divided by 3. All right, so again, today we only have to really plug in one number, the radius. And as long as we have the radius, we're good to go. All right, so let's go ahead and find the volume of our first sphere here. This, we've got our three-dimensional sphere shape, center of it, and then to the outside. And they tell us that this is 9 centimeters. Okay, and that is from the center to the outside, so yes, that is the radius. And remember, the volume of a sphere is 4 times pi r cubed over 3. So if we look at it, 4 is a number, pi, that's on our calculator. Really, the only thing we need is the radius, and do we have that? Yes, it's 9. So let's go ahead and plug them all in. So 4 times pi times 9, but that 9 needs to be cubed over 3. So order of operations. 4 and pi we'll leave alone. 9 cubed, so that's 9 times 9 times 9, and on their calculator that comes out to 729 over 3. Now, you could plug all this in at once. Just to be careful, I usually do the top of it first and then leave the bottom alone. So we've got 4 times pi times 729. So the top number is a 9,160 point, I'll go 88 right now. And then on the bottom, we still have the 3. So we just have to divide this by 3. So it's not really hard work. You just have to not get lost when it comes to the calculator stuff. So in the end, dividing by 3, you get 3,053.6. I'll go ahead and round that to 0.6. And the only thing we need to take care of is the units. So we're using centimeters up here. So I put centimeters here, but if we remember back to the other day, volume, the units always for volume have to be cubed. Because remember, 3D shape. Okay? So there we go. I'll go ahead and box that. So 3,053.6 centimeters cubed is the volume of that sphere. All right, let's take a look at another one. The volume. Now there's not much different that we can make these problems. It's always just going to be a sphere shape. We'll go like this. All right, we have a center. And they show us this. and they tell us that that is 14 meters. Okay, so the volume of a sphere is 4 pi r cubed over 3. And again, we need radius. Now, is that 14 meters the radius? It is not. All right, so the 14 meters, that's actually the diameter. You see how that goes from one end of the sphere to the other? So just like if it was a circle, that's the diameter. That's all the way across. We would need the radius, which is half of that. So if we pull this out here, the radius is actually going to be half, which is 7 meters. Okay, and that's the info that we're going to put in. So we have 4 pi. Instead of r, it's going to be 7, but we need to cube it over 3. So 4 pi. 7 cubed. So 7 to the third power is 343 divided by 3. And again, if you can put it all in the calculator at once, that's fine. I usually do the top, then the bottom. Top comes out to 4,310.26. Bottom is 3. And then finally, divide top and bottom by 3. You get 1,400. Whoops. Not 6 there. 36.8. And my units, again, we see meters up here, but it is volume, so we need to cube it. So 1,436.8 meters cubed. All right. And one last one just for kicks. Again, let's find volume, sphere. Not many different ways we can draw this. Okay. Now, we've got a center. They can draw this any way they want, but if it goes from end to end, that's not the radius, that's the diameter. They're telling us that's 20 yards, so we know we're going to need radius later, so might as well just check it now. Half of that, the radius is actually going to be 10 yards. So finding the volume of this sphere, how much fits inside of this, 4 pi r cubed over 3. We know the radius is going to be 10. All right. So 4 times pi, 10 cubed, that's 10 times 10 times 10, that comes out to 1,000. So 4 times pi times 1,000 gives me 12,566.37. And then last step is divide that number by 3. So the volume in the end comes out to 4,188.8, and my units were yards. Okay, so yards, and don't forget volume has to be cubed. All right, and there we go. We have the volume of this sphere.